Welcome back, Math 0965, to Part B of Section 6.5, where we are factoring completely, bringing all sections 6.1 through 6.4 together. Let's do a few of the problems left on this page. If we jump to letter H, this is a really common problem that you will see that'll say factor completely, right? It's a binomial, so I need to check perfect squares and perfect cubes, right? We can tell right away that x times x is a perfect squared and 8 times 8 is a perfect square. But what should alarm you is that you have the sum here, the sum of perfect squares. And we've looked at in our last lessons why we cannot factor those, right? And so that is your red flag that when you see the sum of squares, right, there is no formula for that. We tried to put in different signs there, that this is prime, right? So keep your eyes open for that and don't fall into any of those little traps there. Alrighty, let's keep going. Let's see, how about letter K? Okay, letter K. Letter K has us, again, it's a binomial where I do see that they have an x in common. Okay, I'm left with x to the fourth minus 81. When I look in the parentheses, I should notice that I have a perfect square, right? X squared times x squared, and another perfect square, 9 times 9. I know I can do this one because I have the difference of perfect squares, and we have looked at the formula for that. So let's break this one down. Bring down that GCF, x, and we're left with x squared plus 9 and x squared minus 9, right? Typically, we would think we would be done, but if I look more closely in these parentheses, I see a perfect square and a perfect square, a sum here, which means I'm done, nothing left to do, but in the last parenthesis, I have a perfect square minus a perfect square, which tells me I have one more step to do in this problem. Okay, let's bring down GCF x, x squared plus 9. There's nothing left to do in that parenthesis, but in that last parenthesis, I can still break it down, right? X times x, a positive 3 and a negative 3, right? Final answer, x times x squared plus 9 times x plus 3 times x minus 3 to give us the original binomial x to the fifth minus 81x. So even when you think you're done, keep asking yourself how you can finish this problem. All right, let's do a couple more problems. Let's look at M and N. Those seem to be a little bit longer. I notice right off of the bat for this trinomial that I have a leading term that's negative, right? So that is going to come out in my GCF. When we look at 36, 62, and 12, right, they are all even. So I know at minimum a 2 is coming out. Okay. You can check the other factors. You will see that 2 will be the greatest common factor here. So a negative 2, as we stated in the beginning, for pulling out that negative in the leading term. How many x's do they have in common, right? X to the third, x squared, and x would leave us with only one x in common. And how many y's in common? 1y, y times y, and y times y times y. So only one y in common. Negative 2xy should be your GCF. Remember, all our signs are going to change, so be careful as you're pulling them out in the parentheses. In our parentheses, we should be left with 18 x squared. Change your sign. Minus 31 xy. Change your sign. Plus 6y squared. So we are asking ourselves, in the parentheses, right, can I still factor? Well, we've pulled out our GCF. The leading term is not 1, right? The leading term is 18, right? Our term at the end is a 6. I can do AC method here with 18 and 6. 18 times 6 is a 108. So I'm looking at factors of 108 that add together to give me 31. Right? So if you start your list, 1 times 108, that's 109, right? 2 times 54, that's 56. 3 times 36, that's 39. And fortunately, when I get to 4 times 27, that does give me 31. And so I can break this down. Okay, so let's stay organized. Bring down that GCF, negative 2xy. Okay, we can ignore it basically the rest of the time. We're going to separate that negative 31xy. And we are going to use 4 and 27 here, right? So what gives me negative 31? Well, when I add together negative 27xy minus 4y, that gives me negative 31xy. Oops. Looks like I missed a little variable here. Okay. And bring down that last term, 6y squared. Again, stay organized in your work. That negative 2xy will come down. Okay. And I will do factoring by grouping, right? So let's see, 18x squared minus 27xy. It looks like a GCF there would be 9x. And what's left in parentheses would be 2x minus 3y. In the next set of parentheses, my leading term is negative. That will come out. They're both even. A 2 will come out. And it looks like they have a y in common. So my next set of parentheses should be 2x minus 3y. Okay, let's get to our final answer. Final answer. Bring down that original GCF, negative 2xy. What do they have in common in the parentheses? It's the 2x minus 3y. And what's left over here? 9x minus 2y. You are finally at our factored completely answer. Okay. Let's try letter N. A lot of variables, right? 4 terms. The first thing I'm checking is there a GCF? Let's see. I don't see anything they all have in common, right? But with 4 terms, I'm going to try the factoring by grouping and see if that helps. Alrighty, a squared y minus b squared y. The GCF here would be y, and we are left with a squared minus b squared. In the next set of parentheses, I see a leading term is negative, so I better take that out, right? And what variable do they have in common? It looks like an x. Let's pull that negative x out, and we are left with a squared. Don't forget your sign changes. Minus b squared. Well, this is good, right? We want our parentheses always to be the same. Our answer, a squared minus b squared, right? And what's left on the outside, this y minus x. Okay. It looks like we're done, but we're always asking ourselves, can we further break anything else down? This a squared minus b squared should look familiar to you. A difference of perfect squares. Final answer, whoops. A plus b times a minus b, right? And bring down that last factor, y minus x. Alrighty, I hope this has been helpful. I hope this helps you figure out when you put all the perfect squares, perfect cubes, GCF, grouping, AC method, when to use and how to use it. Okay, I'll be happy to take your questions. Please email me or ask them in class. Thank you.